This video I introduce a LSTM-based autonomous driving model. Now we develop a self-driving model and train the model on Waymo dataset. First, we introduce a baseline self-driving model that is based on convolutional neural network. We pick an image from a front camera and use the image as the input to the convolutional neural network to output the low-dimensional features. And then I use later to extract the 12 features corresponding to the input image and use these 12 features as the input to the fully collected layers to output the low-dimensional features. And then we put them together as the input to the fully collected layers to predict the acceleration of a self-driving vehicle. Because we use a supervised learning to train the model on Waymo dataset to predict the acceleration of the self-driving vehicle when the model observes this input image with these 12 features. That's just like a one-to-one mapping. Because the driving activity is a sequential behavior, so if we can formulate this problem as a sequential to sequential mapping, then it will make much more sense. To this end, we use LSTM to form a encoder-decoder architecture. So first, we pick 10 images from front camera, and then use the convolutional neural network to extract the low-dimensional features from the 10 input images. And then we use this low-dimensional features as the input to the LSTM module to output the hidden state vector. And then we use the LiDAR to extract the 12 features from each input image. And then we use these 12 features as the input to the LSTM module to output the hidden state vector. And then we put them together as the input to the decoder. Then the decoder LSTM module to predict the accelerations at the next 5 time steps. So this is just like a sequential to sequential mapping. That is much better than the baseline self-driving model. As we know, Waymo has 5 cameras. If we use the image from all the 5 cameras to train the model, we cannot see much improvement. Even in the pilot net self-driving model, use 3 cameras just to make sure the model can recover from the poor position or orientation. So now let's see what the performance of the LSTM-based self-driving model for this one driving scenario in a suburban area. Here we got to use the LSTM-based self-driving model to predict this acceleration in the forward direction, acceleration in the y direction. And then now we can see one is the ground truth from the Waymo dataset. One is predicted by using the LSTM self-driving model. In both forward and lateral direction, they have a very good matching. For more details, please check with this reference. Thank you. Bye.